Hi, everyone. My name is Benjamin Elder. I'm a senior software engineer at Google. I work on Kubernetes and GKE. I'm a member of the steering committee in the project and a technical lead of the testing and infrastructure special interest groups. You might know me as Ben the Elder or elder.dev. Today, I want to talk to you a little bit about Kubernetes and GKE and how we drive improvements in quality together. So, very recently, Kubernetes 134 released. Specifically, it actually released 2 weeks ago on August 27th. This is the logo and brand which is chosen by tradition by the release lead in the open source project each time. So 134, win and will. Something I've been working on that I'm very proud of here at GCP is that within a week of the open source release, at our next rollout window, we rolled out GKE 134 with all the incredible improvements in Kubernetes 134 available right away to our users. A lot of work goes into shipping Kubernetes open source releases throughout the community. It's a lot of work to make sure that they're high quality and well tested. So I want to talk a little bit more about that. You know, my team, it's a big community effort across the whole ecosystem to make this happen, but my colleagues and I are very active in the project and work specifically on some of the things that help make sure that this is well tested, high quality, so on, such as production readiness reviews for enhancements, the testing and infrastructure, and other work. So we can't talk about Kubernetes 134 without talking about DRA. DRA is something that you'll probably hear a whole talks about for an hour. It's a big shift in resource allocation for Kubernetes that replaces the device plugin API, essentially making it more flexible to schedule resources like accelerators. But something you might not know is the DRA is actually tested and developed with Kind, or Kubernetes and Docker, which does local clusters by containerizing the nodes. This is something we worked on and developed in my team and collaborated with people in the ecosystem, including Patrick Oley at Intel. We use a mock driver, and so that way we can test and iterate very quickly on this very complicated new API and get fast CI signal and fast local development with these little local clusters. But on the total opposite end, something else you might not know, every day in open source Kubernetes, we're actually testing with 5,000 node clusters in the cloud. As part of this long-term guarantee the project has had to make sure that Kubernetes is a scalable, reliable foundation for the ecosystem. So for a very long time, this only ran on GCE, but more recently this runs on GCE and EC2. This is thanks to millions of dollars in donations from Google and now Amazon that sponsor the Kubernetes project annually for all the infrastructure for the hundreds of sub-projects and everything that we need to run CI, build and test and release, and all the automation. This makes sure that we have a scalable, reliable base and that we don't have key performance regressions release to release so everyone can build on it. You know, 5,000 nodes might not be quite as impressive today, but this was an early commitment in the project and one we've stuck to make sure that the core out of the box can reach this. So when we talk about that, I want to talk about one particular enhancement in 134 that enabled this, streaming list response. You can see this graph here with the memory usage of API server. This is in our upstream performance dashboard for those 5,000 node cluster tests. And you can see this massive drop off at the end here. That's when a patch landed from one of my colleagues, Marek Siarkowicz, which enables streaming encoding for the list responses from the API server. This is a really interesting one to me because it was such a small change, but it took a lot to get it just right to make sure that it's byte for byte compatible, that you could use existing clients, and that there's zero changes between prior releases and this one, but you get this massive memory improvement, 20x in list responses. Another one was consistent read from cache. When you hear about 65,000 node or 100,000 node clusters in marketing from some of the vendors, this is the kind of work that fundamentally enables it, massively improving the performance of the core of Kubernetes for all the APIs. So I'm running low on time here, but I just want to say all of this is a huge community effort. If you want to come join us, you can find the developer community for the Kubernetes project at kates.dev or kubernetes.dev, whichever is easier for you. It goes the same place. Or you can join us in Slack at slack.kates.io. I'm also free to chat if you want to talk about getting more involved. You can find me at elder.dev. Thank you.